Welcome to Ask and Learn.
Problem number 122. Air is cooled by evaporative water into the air. The amount of water required and the cooling produced are to be determined. Here, according to the given problem data, we will make a diagram according to which it's a water humidifier 70 degree Fahrenheit. Here, the water showers, and after that, the outlet temperature would be of air 75 degree Fahrenheit, while the relative humidity would be 80%, while at the inlet conditions will be pressure at 1 atm and temperature would be 110 Fahrenheit and relative humidity would be 15%. Here we will take three assumptions. The first one, this is a steady flow process and thus the mass flow rate of the dry air remains constant during the entire process. So m dot a1 is equal to m dot a2 is equal to m dot a. Second one, dry air and the water vapors are ideal gases. The third assumption, the kinetic and potential energy changes are negligible. So, the inlet and the exit state of air are completely specified. The total pressure is 1 atm. The properties of the air at the various states are determined from the psychometric chart. So, we will write H1 as 35.6, which we will get from psychometric chart, pound of mass dry air, and specific humidity is equal to 0.0082 pound of mass of water divided by pound of mass of dry air. Similarly, H2 is equal to 34.3 and specific humidity of 2 is equal to 0.0149. Also, as we know, enthalpy of water is equal to HF enthalpy of fluid at a rate of 70 degree Fahrenheit would be 38.08 BTU per pound mass. The amount of moisture in the air increases due to humidification, so omega 2 greater than omega 1. Applying the water mass balance and the energy balance equation to the combined cooling and modification section, so water mass balance would be sigma mass flow rate of water at inlet is equal to summation of mass flow rate of water at exit would be equal to mass flow rate ma1 w into w1 plus m dot w. Now delta specific humidity would be equal to w2 minus w1, which is 0.0149 minus 0.0082, and it would become 0.0067 pound mass of water divided by upon mass of dry air. Now this was the water mass balance. Now we comes towards energy balance, which is energy at inlet is a minus energy at outlet is equal to delta energy of the system would be equal to zero due to steady condition, due to which inlet energy would be equal to the outlet. As we know, summation of m dot I hi is equal to q dot out plus summation m dot e and enthalpy of exit. Here E is the exit and I is the inlet. Enthalpy mass flow rate. Q dot out would become A1 H1 plus m dot W HW minus m dot A2 H2 taking m dot A common H1 minus H2 plus m dot W into enthalpy of water, and here the Q out comes H1 minus H2 plus W2 minus W1 into enthalpy of water. Now put the values 335.6 minus 34.3 plus W2 minus W1 comes out 0.0067 multiplied by 38.08. When we resolve the equation, we will get 1.47 BTU per pound of mass of dry air. Thank you.